Welcome to Vision Plus and welcome back to the Senior Form Mathematics and Complex Numbers. We are now looking at the Argand diagram, and we are saying that complex numbers can be represented graphically on a graph of the real axis and the imaginary axis. And that graph that contains the real and the imaginary axis is what we are calling the complex plane. Complex plane. And the complex plane is similar to the normal Cartesian plane. The only difference is that instead of the x-axis, we shall call it the real axis, and instead of the y-axis, we shall call it the imaginary axis. That is the difference. And the diagram that represents the complex number is what we are calling the Argand diagram. It was named after J.R. Argand in 1806. And remember, we said that a complex number is a sort of a vector quantity. That means it has the magnitude and the direction. We have looked at the magnitude of the complex number, that is its size. And the direction, we shall look at the direction after this concept. So, it is a straight line with an arrow which shows the direction to which the complex number is pointing to. Now, let me break down this concept into simpler terms that you can understand. One, we are saying that if you have a Cartesian plane, and remember, a Cartesian plane has two axes. It has the x-axis and the y-axis. This is the x-axis, and then this is the y-axis. That is the Cartesian plane. Now, if you change the axis, if you change x-axis and y-axis, that gives us now the complex. It gives us the complex plane. What do we mean? We mean if you have this axis, this vertical line and the horizontal line, if you call this horizontal line real axis, instead of x-axis, we are calling it real axis. That's why we are saying that the x-axis corresponds to the real axis. And then this y-axis, we shall call it the imaginary axis. Now, the moment you have the real axis and the imaginary axis, this one now becomes the complex plane. It is no longer a Cartesian plane. Now, when you go ahead to draw or to represent a complex number on the complex plane, that gives you now the Argand diagram. So, an Argand diagram is simply a graph showing a complex number on a complex plane. And assuming we have a complex number, assuming we are given a complex number z as x plus iy. Now, this is the real part of the complex number. Now, the real part of the complex number z is x, and the imaginary part of the complex number z is y. Those are, remember, x and y are variables. They depend on a given complex number. Now, for it to be an Argand diagram, the complex plane must carry at least one complex number, because we represent very many complex numbers on the same complex plane. So as long as there is a complex number on the complex plane, that drawing or that graph becomes a Argand diagram. This is the real axis. In most cases, we just say this is the real part of z. This is the imaginary part of z. That is how you represent it. Now, this is our z. Now, what is the real part? Now, the real part is x. X is positive. So, somewhere here, you can say, assuming x is here, is positive. Y is also positive. Is on the y-axis there, which now we are calling the imaginary axis, which is the vertical line. And then you get the point of intersection of these two lines. This is now where they intersect. So you draw a straight line with the ruler, a straight line from the origin here up to that point of intersection of x and y with an arrow on it, with an arrow at the top. And this is the complex number z. Now, this is now what we call an Argand diagram. So an Argand diagram is simply a complex plane representing at least one complex number. So this is the overview of what we are going to do when we are looking at the Argand diagram. Let us go to example 1 and then we'll see how we can represent complex numbers on the Argand diagram.